Right, hello everyone. My name is Joel. I am one of the tutors for CSSE1001, and today I'm here to give you a few tips and tricks for assignment 1. So how this is going to look, this video will run for roughly 10 minutes. I'm going to run through the assignment and go through a few of the consistent problems we've been seeing a lot of students facing over the past week who have started the assignment. I'll give a bit of a brief overview about the assignment and the best way to tackle it. I'll also be going through some just general advice for how to approach bigger tasks and where to start. And finally, I'll be talking about how the marking will work in the assignment. So how to divide your time between prioritizing functionality and prioritizing style as you get marks for both of those aspects. And it's important to make sure you complete both. So to start off with, I thought I'd just give a brief introduction to the assignment. By now, I assume many of you would have started your assignment. So you would know that assignment 1 is to recreate Wordle in Python. So if we just run through here, I assume many of you have played Wordle. If not, I would encourage you to go online to play it first to get a bit of understanding of how the game works. So the process is basically you will put in a word. In our case, we're using 6-letter words, and then we want to determine which character is in the word and which character is in the right position. And then the user will get another turn to guess, and they need to guess the word before the total number of guesses runs out. So this assignment, if you look through the document, it can look a bit big and daunting. However, for these first 3 sections, it just provides a bit of an overview of how the game works and some of the functionalities we're actually adding into the game. Section 4 as well just provides a bit more background about some of the input assumptions that some you might need to be aware of, and others it's more so that these will be handled automatically. And finally, the part that you're really going to be focusing on, and this is the part where you actually need to start doing the work, is section 5, implementation. So for some of you, you might be thinking, well, where do I even start this assignment? Given it's your first one, many of you may have not done Python before. It's a pretty valid and common question we get. So what I suggest is run through section 5 onwards in order. So these functions are more or less in the order of easiest difficulty to hardest difficulty. And in addition, a lot of the later functions you have to write will actually depend on some of the earlier functions. So it's not a good idea to write some here and write some there, but rather go in order, one step at a time. In addition, you might think it's daunting to look through all these different functions you have to write. One piece of advice I'd give is to treat it like multiple MyPyTutor activities. We're giving you a number of functions to write. So think of it as if it's one big MyPyTutor activity, one after the other, and then it all culminates in the writing of a main function, where you stitch all the functions you've written together to create a formulated and working Wordle game. So as you can see, we've listed a number of functions. We've told you how the definition should look. So if you're wondering how to write the function in the first line, it would be this here, beside the 5.1, 5.2, etc. In addition, we provide a description of what the function does. And finally, what we also do is we provide some examples so that you can test yourself before you submit your code. So if we run through, we see a number of functions that we're asking you to write. And then, as I said before, they all run in order of increasing difficulty. And finally, we'll ask you to write a main function. And for those doing the postgrad version 7030, there is a bit of extra functionality we are requesting that you write as well. I'll touch on the main function a bit later, but for now, I'll start by going through some of these functions and some of the common questions that us as tutors are getting and some of the common problems we're seeing with people's assignments. So the first place I'd like to start is the fact that we have actually given you some documentation to do your assignment. So this documentation is in the A1 folder. So if I show you here, if you download A1, we give you 2 Python scripts, A1.py and A1support.py, as well as the answers and vocabulary text documents. So the first problem we're seeing occur with a number of students is that many people are copying and pasting their support file into the A1.py. You do not need to do this. This is something that would breach the style guide. So what you would do is if you see these functions here, load word and choose word, which are functions that you will be using in your assignment, don't copy and paste these into your assignment. Rather, you can call upon them. So for instance, if in main, I wanted to load words, I can see up here that load words is actually already being imported from my support file. So all I will do is I'll type load underscore words, and I will type in the file name. So for instance, I could type in my file.txt, and that's the file name. In this case, we give you 2 files with file names, vocab and answers, and these are the file names that you'll be using. Similarly, for choose word, what you would do is you would write choose word, and you would put the input argument, which is a tuple containing strings of words. And we're going to get to type hints a little bit later on. So that's the first piece of advice. Do not copy and paste the support file into your a1.py, but rather you can call the functions, and you can even call the name symbolic constants that were given you at the top of the file. The next thing I want to touch on is a point where a number of students are getting confused. So this point is to do with type hints. So if we go and open up the spec again, we can take a look at the type hints. So looking at these functions, we can see, for instance, in the first function has one, it contains two parameters. We have a parameter for guess and a parameter for answer. After the colon, we have what is called a type hint. So this tells us what the type of the input parameter will be. So in this case, we can see that the guess and the answer are both meant to be strings. This arrow over here indicates a return. It tells us what we're going to be returning. And it's telling us that we're going to be returning a Boolean. So this is essentially how to interpret type hints and what they mean. Similarly, if we look at has lost, what we see is we input a guess number, and that guess number is of a type integer. So we're saying that an integer is going to be given as an input, and as an output, we're going to be returning a Boolean. One thing we're seeing students doing with this, particularly with the returns, is that they will read that they're required to return a true and a false, but instead of returning, they're actually printing. So for instance, if we're requiring you to return true or false, and I'll just write this up in a script here. So I'm going to write a script, my function, and it's going to take in an argument. And this argument, what it's going to do is I just want it to return the argument. What a number of students are doing is they're just going to print arg1. However, this isn't correct in what we're asking for. What we're asking for when we're asking for a return is not a print, but rather we're saying we want you to actually return a particular value, in which case we would be looking for this, if that's the function that we were asking for. The same thing goes here in has1. We're not asking you to print true or false. We're asking you to return true or false. So anytime you see one of these arrows pointing to a particular type, it means we want you to return that, not to print it. If you're wondering about occasions where maybe you will need to print, these will be times when we specifically ask you in the code that you'll be required to print out certain values. And it should be very clear, hopefully, from the way that the spec is being written. So if we keep scrolling through, we'll see a few more type hints, which are also causing a number of students to get hung up. Some of these are a bit more complicated. So we've touched on strings, integers, and booleans, which seem to be quite clear. But other ones here are like tuple, which contains a number of strings. So this here is saying that the input parameter words is going to be a tuple containing strings. So not just one string. If it was one string, it would just have str here. But rather, since we have ... it means it can continually contain as many strings as possible, up to what the user desires. So if I open the shell again, in this case, an example of words would be a tuple using the brackets, and then I can put strings in there. So I can put strings for cat, dog, and I can keep going for as long as I want. And then I press enter, and this would be an example of a tuple containing strings. Another one based upon this, which is also a little bit more complicated, is this one here. So with update history, we see a data type where history is a tuple containing tuples which contain two strings each. Now, in this case, what we can do is I can show an example of what this looks like. So if I open this again and I just write a generic tuple containing two strings, it would look like this. So history, let's say, is a tuple. That's the first one, and it contains multiple tuples. Let's say it contains 3 tuples inside of it. 1, 2, 3. And what each tuple contains is 2 strings. So what I'm going to do is I'm going to write 2 strings in here: cat, dog. I'm going to write dog, cat in this one. And finally, I'm going to write cat, cat. And that would be an example of a tuple containing 2 strings. Now, in your code, what we're asking you to do is we're asking you to correspond this to the history, and we give you a bit of information about what these strings could be. And that's part of this work that you'll need to do to figure it out. The next point that we're seeing coming up quite often is in the handling of other user inputs. So this is particularly in prompt user, when we actually ask the user to we prompt them for the next guess. What's happening is that many people don't know how they're meant to handle the 3 extra commands of help for H, keyboard for K, and Q for quit. We're seeing a number of students, what they're doing is that they're actually printing out the messages for help, they're printing out the messages for keyboard, and they're printing out the messages for quit in here. That should not be happening in the prompt user. So in prompt user, what should happen is that we put a guess in. If the guess is valid, which means in this case, it's a 6-letter word, which is contained in a dictionary, then what it does is it returns that same word. So that's what we're saying here. It returns a string of the guest user inputs. In addition to that, let's say if the user enters a H, a K, or a Q, obviously that is not a 6-letter word. However, we still require this function to return the H, the K, or the Q. So not only does this function return the valid guess, but it will also return the H, K, and the Q that the user inputs. This function will not contain prints, which will do the error handling or the message handling rather for the help, the keyboard, and the quit. That's something to keep in mind. That will happen later on in the main function. So the next point I want to touch on is a general overview for how all this will come together. So what we're asking you to do in this assignment is we're asking you to write a number of functions. And at first you might think that this is sort of scattered. How are these going to come together? And it can be a bit difficult to process this all at once. It can seem like quite a large task. And you may have seen Peter O'Shea's video, which covered the actual running of the game and how it would look. And you run your assignment, you think, well, the way I'm running it, it looks different. I don't have a full game. I only have certain functions, and the outputs I'm getting, it doesn't look similar. So what I want to touch on is basically how this all comes together. So as you're testing, you will not have a working game of Wordle. You will only have a working game of Wordle once you have finished the main task. Now, the main function that you have to write down the bottom, this is what you're required to do last. Don't write the main function until you have everything else set up, because you won't have a working main function until you have all the other functions working. In addition, you can still do fairly well in this assignment just by having everything set up prior to the main. You are better off having all the functions working individually and having some of the main implemented than having a full main implemented with a number of the functions not working properly in terms of marks, because errors in the previous small functions will carry through to the main, and then it'll be added up there as well. So the best way to approach the main function, because this can be quite daunting, is to think about breaking it down. In the main function, you're going to be calling upon a number of these functions that you've written previously. And from first look, it might be difficult to think about how you would do this. And what I would suggest doing is to actually go into your main function in your code. And what you'll do is actually write the steps of what's going to happen and how my code is going to be processed. So for instance, you might say, what I need to do is I need to get the game running, and the game's going to run continually. So maybe we need a loop. Maybe it'll be to do with how I know in the main I'm going to have to prompt the user for a guess. I know in the main I'm going to have to see if the game has been won or the game has been lost. I know in the main I'm going to have to check if the user has entered for a help, a keyboard, or wants to quit the game. So I know all these things will sort of belong in the game, but then in addition to that, what we should also do is we should plan before we write. This is important. So either you can draw it on a piece of paper, you can write it as comments in your code and think about step 1, this is what I need to do. Step 2, step 3, step 4. If that is still a little bit confusing, one of the things that can help is to actually look at the example main function code that we would have provided. So for instance, in the spec, we have provided some examples of what can happen when running a main style. I am just trying to find it. Oops. Or similarly, what we can do is we can actually go to the examples here. So if I open CSSE1001 example text, which we give you, you can actually see an example of how the game will be run. So if you look at this, you'll see that, oh, I recognize that this part here came out of a certain function that I wrote previously. So I know it has to go on this step. I know that the prompt guess is the first thing that appears. So I know this sort of needs to go up the top, and so on and so forth. And then you can see a number of conditions what happens when you just enter different values and how that works. So if you're wondering what steps to write the main in, I would suggest looking at this CSSE1001 example text file, as it contains an example of the main game being run. Similarly, I would encourage you to watch Peter O'Shea's video, as that gives a live demonstration that might be more clear. Additionally, some of you might notice that your colored squares aren't appearing properly. Now, this can be related to an operating system issue, and that's okay. It won't affect the functionality of your code, but it might affect how it looks to you, and you might want to change that as well. So what you can do, if you notice that these are looking washed out on your particular operating system or they aren't appearing properly, you are more than welcome to replace them with other values. In the meantime, just to make it a bit clearer, if you'd rather do this, for instance, you'd rather replace them with characters which are possibly more representative because the emojis aren't appearing properly. This is another way to do it, as you'll be uploading your A1PY to Grayscope. And what we would also encourage you to do is also make sure you test this with Grayscope prior to uploading. So this is something you can do if you choose to, if you'd rather have something else which sees a bit more clear than if the colors of your emojis are washed out. And additionally, we also recommend using idle for testing and running this assignment. We know a number of you are using different IDEs, but we highly recommend running the assignment on idle, as that's sort of a similar base as what your assignment will be running on Grayscope. And there can be issues with different virtual environments causing issues with code running and looking for file paths as well. So before you run your assignment, you submit your assignment, make sure you run it in idle, as it gives the most holistic approach. Finally, I want to talk about how marking works in this assignment. So this is important because many students will simply focus on writing the functions and spend all their time writing functions, and additionally spend all their time writing a main, and then before they know it, the deadline has been reached and they haven't done any styling. So if we go down to the marking down the bottom here, you see there are two key areas of marking. We have functionality and we also have code style. So functionality is basically, does your assignment work? This will be marked using Grayscope through the computer, and you'll receive 6 marks, or 60% of your grade for this assignment is for functionality. The other 40% is for style. So, which is why it's so important. You could do an amazing job on functionality and get all 6 marks, but if you don't do well in style, you can still only come out with 60%, as opposed to 80, 90, or even 100%. So it's important to consider style. So what do we mean by style, and what are the things we're looking for? Well, we've given you a descriptive outline here of what we're looking for in style. The first is program structure. So we want to make sure that your code logic makes sense and it flows. This also includes including white space between functions, making sure you're not pressing things, squeezing them all together. Think about like how you write an essay, you put in paragraphs, having white space, a line of white space between functions, and even using white space within the functions themselves. Descriptive identifier names, making sure your variable names make sense. Don't just call variables A, B, C, D. If your variable represents a guess, perhaps call it guess. If your variable represents a history of guesses, maybe call it history. So you have a number of variables which should indicate what they actually are. One thing is to not use Hungarian notation. So an example of Hungarian notation is basically when your variable name also contains the type name in it. So for instance, if I said my list, this would be an example of Hungarian notation. This is not something that is good for style in Python, and it'll be picked up in this course as well. So avoid using Hungarian notation. In addition, named constants. So instead of, for instance, using constants over and over and over again, what you can do is you actually create named constants. So for instance, we've given you some named constants. So we've given you the constants for incorrect and for unseen and for misplaced and correct. And we've also given you the constants, like I said before, for vocab file and answers file, so you don't need to type these out individually. It's important to use these constants. It's also, you can also go and create your own constants if you want to add more. So that's totally acceptable, and it's something we actually encourage as it's good for style. Additionally, think about your logic. There's a portion designed for logic. So are you duplicating lots of lines of code in your program? Or are you relying on function calls to call upon stuff you've already written? Are your variables being declared locally? In other words, don't use global variables. And finally, control structures. Are your loops and your conditional statements appropriate? Are you nesting heaps more than you need to, or is your nesting sort of at an adequate level? And if you're unsure, you're more than welcome to ask the tutor in the practical. Finally, documentation. This is the part that gets neglected the most and is worth a lot of marks. Comment clarity. So this is important in terms of how you actually comment your code. If you have big sections of code, Think about commenting sections of it. You do not need to comment every line, but rather comment big chunks, maybe 4 statements with 4 lines with if statements inside them, just describing vaguely in a short sentence what this does. This handles user guest processing, things like that. We don't need long paragraphs of what things do. Additionally, informative docstrings. Every function you write needs to have a docstring. If you're wondering how to write a docstring, we've given you 2 examples in the support file. Docstring should be written exactly like this. First line containing a description, the second one containing parameters with the variable name of the parameter and the data type, as well as what that parameter is. And finally, a return. What are we returning? What's the data type of the return? And what does this mean? That's how you're meant to write docstrings. This is how they should look. And we encourage you to write it in this format, as if you do it this way, you'll be guaranteed to get the marks. And finally, description of logic. So if you have large box codes like before I was saying, make sure you break it up and write a few comments to indicate what the code might be doing. So that way it's easy for a user to read and it's easy for us to read. If you're unsure about any of the stuff I've spoken about in terms of style, as it can be a bit tricky at first, feel free to ask the tutor in your practical or on Ed, and we're definitely happy to take a look and give you some advice and tips before the assignment's due. That's all I have to share for today on assignment 1. I hope this video might have been helpful for some of you. I hope that, yeah, you'll start the assignment now, but if not, get started as soon as possible, as it's important to have more time to get the assignment done than less. All the best with the assignment, and yeah, I hope it all goes well, and we'll see you back and getting ready for assignment 2.